Hello, Allied Health, and here we are on skeletal bones. We're going to do the skeletal system, and I have a couple pictures for you there. So on the left, what is that? Take a look at that. We think of bone as so solid, but actually that's microscopic, and it does have these openings like this in bone, and then the cells would be all in these little trabeculae. And here, of course, is our skeleton. So I want to tell you a little bit, some interesting facts here. One is that bone absorbs lots of foreign elements, like lead, for example, which isn't wonderful, right? So this is Beethoven, and we know that he was really sickly. He was sickly after his 20s, and he died young. 56 is young. And when they tested, and I'm not sure how they did this, to test, posthumously, the lead levels in his hair were 100 times larger than that in some normal individual. So he had great contamination. And then they looked at his bones. And in the bones, they also found extremely high levels of lead. All this to tell you that that bones will store some of these toxins. It kind of sequesters them away, takes them away from the blood, and puts them somewhere, puts them in the bone. And radioactivity in bone cancer. So this is a picture of Madame Curie, and she won the Nobel Prize in Physics very early in 1903. She was some amazing lady because she didn't just do that. She then went on to win the Nobel Prize in Chemistry in 1911. Unheard of. And so she was a pioneer in radioactivity, and it was kind of a sad story. She worked with absolutely no protection. She died of bone cancer. And, this is a quote that I want to read you. She carried test tubes containing radioactive isotopes in her pocket and stored them in her desk drawer, remarking on the pretty blue-green light that the substances gave off in the dark. Oh, my. And this problem ends up being shown in the bone. This is where her cancerous cells start to initiate. So the general features of bones, let's jump to that. We have a certain vocabulary that goes with that. And this center portion of a large bone is a diaphysis, and the ends are the epiphyses. Okay, diaphysis and epiphysis. But the other interesting thing is that red bone marrow, which is where you're manufacturing new cells, and in a bone cancer you failed to do that, is this area here in the epiphyses, okay? And then along the shaft or along the diaphysis is where the marrow cavity is, fatty. And these ends then are spongy bone. So spongy bone doesn't have the same compact aspect as it does in the shaft or in the diaphysis. So in my list of vocabulary there, I have compact or dense bone and spongy bone, which is in the extremities, and then periosteum. Periosteum is it's a dense connective tissue, we've talked about those, which follows around the bone. It sort of surrounds the bone. And it's going to be where arteries and veins anchor, where they're able to anchor through this layer and irrigate the bone itself. So this is an example of compact bone here, and you can see how it has this sort of very solid area, compact, and then some of the spongy bone here that I showed you that first picture of. So all those osteocytes are in these little trabeculae of the bone. There's a nice picture of the periosteum. So this would be the bone region, and then this dense connective tissue which coats it on the outside of the periosteum. The functions of that is it's going to protect the bone. It's, as I said, it attaches vessels. It's going to participate in growth and repair. It's just essentially taking care of this bone. And we need to learn the names of the different cells that are in bone. So if it's a blast, it's a new cell. So an osteobone blast is a brand new young cell in the bone, an osteoblast. The periosteum, the fibers of the periosteum are actually interwoven with the tendons. So this would be a tendon, and the periosteum is on the surface, and it'll branch out into the tendon. So it's a huge anchor. It's going to be anchored in there. Because just imagine this muscle here attaching onto bone, and you don't want it to just sort of snap off, right? So it's sort of feeding through this periosteum that's strongly attached onto the bone underneath. Those attachments are called perforating fibers or Sharpie fibers. Okay, endosteum. So periosteum outside, endosteum inner lining. And this is also full of osteoblasts. You're always remodeling bone. This is very important to remember that you're right now, as we speak, as you sit there listening, you are remodeling your bone. Okay, so these osteoblasts are going to do that. And they're going to, in order for a bone to grow in radius, we break down the inside and deposit on the outside. So it's going to end up growing like when a child is growing, for example. So blast indicates growth. An important thing to remember is, for when we think of broken bones, how do you break a bone? Bone was designed to be both hard and flexible, right? So it has some components that make it very hard and some components that make it flexible. You want it to give a little bit, right? You don't want it to snap on you. So it's those two components that are going to make bone perfect, as perfect as it can be. So what is the matrix? Remember that term matrix. It's mostly hydroxyapatite crystals. So they're crystals of calcium and phosphate and calcium carbonate. So think of calcium. Calcium phosphate is making up the majority of this bone that's making it hard. It also has magnesium and sodium, potassium, but really if you just remember that it's calcium, calcium phosphate, and calcium carbonate, that's where we want you to be. 30% of it approximately, as I mentioned up here, 85 and 30, those don't add up. So it's approximately 80, approximately 30 is made of collagenous fibers that make it flexible, right? So you want it to have a little bit of give. I'll put a clicker in here. The type of bone that holds a tendon farther from a joint, preventing the tendon from pinching itself. Oh, I didn't tell you what this is. So this is the sesamoid bone. I'm going to skip over this. When a tendon goes over a joint, that can create a problem because the tendon can get pinched inside there. So we have some bones which are very nicely located at the location of a joint, and that's going to make it so that that tendon is farther away from it, preventing getting pinched. Sesamoid bone. Okay, the cells are osteoprogenitor cells, which is stem cells. So a stem cell is the cell that's always reproducing. Let's see if I can get out of my own way here. They're multiplying continually, and most of them are going to become an osteoblast. That's a young bone cell that's going to then become an osteocyte, which is an adult cell. Okay, and these are found in the bone marrow. So again, marrow is housing these. Osteoblast. So from the osteoprogenitor, we're moving on to the osteoblast. These are the ones that are going to secrete the matrix. Important, right? That matrix that we talked about before. And it's going to mineralize the bone. So when bone is first being formed, that mineralization isn't there, and it's going to come from the secretion from these osteoblasts. And osteocytes. So cyte is a cell, osteo is bone. These are the mature bone cells. And they will live inside their little caves, which are called a lacuna. Okay, and they communicate with each other. Cell communicates to cell via little canals, and those are canaliculi. So very hard to be a bone cell because you're stuck. You're stuck inside a space, but you can't connect with the others through little canals. Okay, that's how it works. These are the most amazing osteoclasts. They actually dissolve the matrix, and they do that by secreting hydrochloric acid. They do it hydrogen ions and chlorine. I was first horrified when I was reading about these the first time because I'm always thinking of osteoporosis and how to prevent that. And to think that we actually have cells that do exactly that, dissolve the bone, is sort of confusing. But you need to do that. In the remodeling, you're breaking down bone, depositing new, breaking down. If you have a fracture and you have little bone splints, those are going to be broken down by the osteoclast. Okay, osteoprogenitor. Let's go back. Osteoblast, osteocyte, and osteoclast. That is what makes up bone. I've posted an MGIM video for you to see on Canvas. I'm going to skip these clickers right now and go to what we see macroscopically. We see these thin plates in the spongy bone, right? And those are called trabeculae. And the orientation of those are in such a way that they were going to take a lot of force. So this is a femur. So think of your upper body pressing down on a femur, and this is going to have to be reinforced because this is where breakages happen, right? You hear of the little old lady who fractured her hip. So that's here. So this can end up being a very weak spot, and this is where these trabeculae are oriented in such a way, not all in the same direction, so that they have greater strength. This is what bone looks like microscopically. Remember, you have the center artery, and it's feeding all the cells in these concentric circles. Bones, microscopically, very different from other cells. That is a picture of what I showed you, but with a diagram showing what an osteon would look like. You have an artery and a vein, and then rows of cells surrounding these that are going to be irrigated by that artery and then drained by that vein. It makes it very strong because the orientation is in different directions. So if you have these concentric circles making up your bone, it's going to make it for a greater strength. Now, that one region irrigated by the one artery and the vein is called an osteon. Okay, so bone is made up of hundreds of osteons and surrounded by collagen fibers. I'm going to stop this here and continue on later on how bone is formed. Thanks for listening, guys.